Okay, so in the next part here, we're trying to compute the standard deviation. Okay, so the standard deviation is generally used to measure the amount of variability in the data set. Let's say you have a set of numbers, right? Are the numbers all roughly about the same, or are all the numbers very far from each other? For example, is your set of numbers like 2, 3, 4, 3, 4? So if these numbers are 2, 3, 4, 3, 4, these numbers are very close to each other because they're only different by 1. Yeah. So the variability in this data set is low. But what if the numbers are like 10, 1 million? Sorry, I don't know whether I put in 6 zeros. Yeah, 6 zeros. 10, 1 million, 12, 100, 1000, sorry. Yeah, and then 32. Okay. So now this data set, let's say this is a set of 5 numbers, right? If we compare this to a set of 5 numbers like this, 1, 2, 3, 3, 2, right? These numbers are not highly variable because they do not have a high amount of variability because the numbers are all very close to each other. The distance between 1 to 2 is very close, 2 to 3 is very close, 3 to 3 there's no distance, 3 to 2 there's only a distance of 1, right? So the variance is very low, or the variability. This is what we measure in standard deviation. But in this case, you see, this set of numbers is a bit strange. Yeah, first number is 10, second number is a million, third number is 12, fourth number is 1,000. Yeah. So do you have real scenarios like this? Yeah, maybe it can be the income of people. Yeah. We have super rich people and we have people who are working part time. Yeah. Or we have our normal people. So this data set can actually be income. Yeah. Or there can be other data sets and so on. So there will be data that is highly variable. And we can see the amount of variability by using standard deviation. Okay. Now, if you want to calculate standard deviation, let me get rid of this. Now, if you want to calculate standard deviation, this is the formula, but we are not going to try and use the formula. What we are going to do is instead, we are going to use the built-in formulas. Yeah. All right. So doing this by hand will be a bit difficult. Yeah. But we are going to use the built-in formulas that is already offered by Excel. Okay. So again, we are going to go back to the sale of water CSV file. All right. So we were here. Now, this time around, we are going to do equals to stdev dot. Okay, so now this is the standard deviation formula. Now, when you type standard deviation, st is standard, dev is deviation, dot, they give you two possible choices. Yeah, dot, either dot p or dot s. Yeah. Okay, now p stands for, let's get out of this. I've filled the formula in it is an incomplete formula. So whenever there's an incomplete formula, there will be invalid error and so on. So we can ignore this for now. I just want to explain what is P and S, right? So P stands for population and S stands for sample. Okay. So in statistics or in statistics, what we do is whenever the population is very huge, imagine if this data has got 2 million, 3 million, or 10 million data sets, trying to run these formulas on everything will be quite difficult. So usually what happens is, from the data set itself, there will be a sample that is extracted in statistics. Okay? So the sample will be a useful determination of trying to find out what the population is like. But in our case, we are not going to be doing statistics. We just want to try and figure out, given a particular data set, and this data is not very long, yeah. So we are not going to be using the sample version. We are just going to be using the population. Okay. So it's going to be dot p. All right. So you open the bracket again. Now, in this set of values, what is the amount of deviation? And we hit enter. And we can find that this is the calculated amount of deviation between the numbers.